Yeah, good evening. Yeah, I'm sorry, we have a little delay. Yeah, I'm going to share my screen now. Okay, I see this is actually here now. Okay. Hmm. We are in week 3 now. Okay. Start the VMF Masterclass tonight. And that's week 3. I'm sorry. That's supposed to be week 3. And today's 18. Next one. Yeah, okay. Good evening. Good morning for those in Canada. I don't know what time is there now. Yeah, today we are going to discuss again. It's a masterclass week 3 that we start tonight. Is brought to you by Danvan in collaboration with Smart Green Ships Limited. The aim is today to discuss again the VMF. The VMF concept is a kind of integrated HVAC for green building, mostly for green building solution. That is a bit the idea. So for those who have any project who maybe who have been follow us since the last 2 weeks now, there's a possibility for you to submit a project. You can submit a project by scanning the QR code that you can see online there. I mean, on your screen, there's a QR code that you can see, so where you can scan and submit your project. Yeah, tonight again, what are we going to cover? I just wanted to introduce to you the VMF, the ultimate energy saving total HVAC. When I mean by total HVAC concept that I'm going to explain, that's exactly the aim of this master class. It's about explaining exactly what is a VMF, what's the VMF, I mean total HVAC concept. We will provide heating, ventilation, air, AC, let's say that in total. So my name is Dr. Bless Mempo. I'm a Denver Africa Market Development Lead. So we have been working this last year now to try to promote the VMF mostly in Africa and the UK. So what am I going to cover today? Today we're going to discuss a bit about the new era. What I mean by the new era. Welcome to the new era of commercial HVAC with hybrid VMF. So I need to explain, I need to introduce again, because that is exactly our concept is about. It's all about put it in, bring in a new era of HVAC, which I'm going to explain soon. And then I will have a focus exactly on that VMS. What is VMF? How does that replace a tree VRF, air under unit and the dehumidifier? How did that come all together? So, and then I will try to make a difference now between VMF and the other technology that will be discussed mostly when we get to the case study, Snapshot. So we're going to discuss that in further. There's a short video also. I also prepare for that to exactly discuss a bit the comparison between the three main leading, let's say, HVAC system in the market. So now how VMF accelerate edge certification is not only focused on edge, it can also be used for other certification like LEED or BREM or any other certification. But here I focus most on edge because the edge is kind of more used in developing countries, let's say mostly in Africa or maybe India or other countries. Most use is edge with more I'll be applying there. So I would focus a lot on edge, because recently also the other advantage with edge is that it's connected with the green finance. So there's a kind of more motivation to discuss about edge, how that can be integrated with edge. And then I will go through the small case study and then call for project. If there's any question, please be free to drop the question on the chat on the chat box. So I will reply to you. I will come back to you soon as soon as I have a chance to get there, or I can also reply to you later. if I don't have the time to get to to cover those questions during this live session. So again, thank you again. Thank you all of you again to find the time to join me tonight again to discuss this weekly event. It's about discussing. It's about having a chat around VMF. So that the introduction. By the time maybe with the time we'll make it more. It's kind of simple chat, but this I need to present the VMF first, and then with the coming week we will see how we shape it can take to make it more maybe more interactive for all participants. So, like I said before, welcome. What do we say? We can say at Danvern, we didn't just improve HVAC. I want to explain this one very clear to you, because what I mean, you look at it at the beginning with a traditional HVAC. There is a kind of a system. The system was completely built around the refrigerant heavy. What I mean, so you can see most HVAC, the most efficient one in the market, they have a refrigerant inside the building and outside the building. So the refrigerant quite everywhere. So it's really based on heavy refrigerant base. And then another one is recirculation. They use the recirculation. That what I mean. What I mean. If you look inside the building, if you look inside the if you look inside the building, if you look inside the I'm sorry, I don't know what people are calling me now. If you look inside the HVAC system, there's normally cassette, most time cassette or fan coil, where the air distributor, where the component will distribute I mean, we put the condition inside the building. When you use cassette, they use recirculation. What I mean, they use the air internal, the same air inside the building. They just renew it, they don't refresh it, kind of using the same air, turn it around the cassette to provide you the condition. They also they recirculate the same air to provide to you. That is how it be the base about. And then another legacy from the previous climate control system, like HVAC, the conventional HVAC system, is what exactly is. They have separated unit. Most of the time, they're separated unit. The air conditioning will be separate for the ventilation with the air handle unit, and then also with the humidity control unit, which is also alone. Or if you want to integrate BMS, most of the time BMS is also from another manufacturer. All those as different manufacturers coming together to provide to you the the innovation, the air conditioning system, the complete HVAC system. So we at Denver, what do we ask? We ask we ask a different question. What if one intelligent system could do all the 5 main functionality in the market while providing 100% fresh air? So at the same time provide very low energy consumption. So that is exactly the question we ask ourselves, and that how the hybrid VMF was born. So the hybrid VMS system was born based on that simple equation. So we want to provide it to you. If I can to summarize, we want to eliminate the recirculation, we want to eliminate a lot of components, a lot of manufacturer around the same around a project. We wanted also to not based on recirculation, but on fresh air all the time. That then we didn't want to be controlled manually, be controlled by a brain. So that a bit what the new area we're bringing. That what we call the paradigm shift from legacy climate control to a hybrid VMF solution. Hopefully that is the idea behind this. So if you want to focus on the system, so how one unit can employ 3. So in this short video, you can explain that to us a bit in detail. So
today, we're going to talk about a piece of tech that is completely changing the game for how our biggest buildings, well, how they breathe, stay warm, and keep cool. It's called a VMF system, and honestly, it's a huge leap forward. But to really get why it's such a big deal, we first have to look at the problem it's built to solve. So let me ask you something. When you picture a big office building or a hotel, what do you think is using up the most energy? Is it all the lights? The thousands of computers? Or maybe something else entirely? Yep, if you are thinking it's the climate control, you are absolutely right. The amount of energy is just staggering. In a normal commercial building, the HVAC system, that's all your heating, ventilation, and air conditioning, can guzzle down anywhere from 38 to 55% of all the energy used. That is a massive slice of the energy pot.
And that really brings us to the core of the issue, doesn't it? Our buildings have a serious energy problem, and the way we've been doing HVAC is right at the center of it all.
Think of it like this. For decades, the climate system in a big building has been like one of those old component stereo systems from the 80s. You've got a separate box for the heater, another one for the AC, one for ventilation, maybe another for hot water. They're all kind of Frankenstein together with a mess of wires and pipes, and they don't really talk to each other. It's complicated, it takes up a ton of space, and it's just not very efficient. So if the old way is that clunky stereo system, the solution is much more like a sleek, modern smart speaker that does everything in one. And that, right there, is where VMF technology comes into the picture. Okay, so what is VMF? It stands for Variable Multi-Fluid Flow. And yeah, it's a commercial air-to-water heat pump, but the real magic is how it puts everything together. It takes all those separate jobs, heating, cooling, fresh air, hot water, even managing the humidity, and it packs them all into one single super smart unit, the whole shebang. So instead of a whole room full of different machines, you just have one smart unit doing 6 different jobs. And it's not just about putting them in the same box, it's about making them work together perfectly under one brain. Let's just follow the flow for a second. There's a single master unit, usually up on the roof, that does all the hard work. It treats the air and water, and then, and this is a key part, it sends treated water, not refrigerant gas, down into the building. That water flows through these special units in each room that quietly use its temperature to either heat or cool the space. It's elegant and simple. Now, this all-in-one approach isn't just a neat trick. It has some incredible real-world benefits. The whole system ends up being smarter, way simpler, and a lot healthier. So let's break that down. Okay, let's get into the numbers because they are pretty dramatic. Compared to a standard conventional system, the kind with separate refrigerant units and big air handlers, a VMF system can use 75 to 100% less energy. No, that is not a typo. We're talking about, in some cases, doubling the efficiency. It's wild. And because it's so much more efficient, it just needs way less power to run in the first place. The total power you need to install can be 50 to 75% lower. And that means less stress on the power grid and way smaller requirements for those expensive backup power systems. This one is all about your health. VMF systems are designed from the ground up to use 100% fresh outside air. So there's no recirculating stale, old indoor air, which is something older systems do all the time to try and save a little energy. Here, the focus is just on giving you the cleanest, freshest air possible. I mean, when you put them side by side, the difference is just night and day. On one side, you've got the old way, a bunch of separate units, a massive footprint, super complex installation, and you're often breathing recycled air. On the other side, you've got VMF, a single compact unit that's basically plug and play and guarantees you're getting fresh air. It's a completely different philosophy. So how does it pull this off? Well, if you look under the hood, it's packed with smart tech. A huge piece of the puzzle is something called heat recovery. The system literally captures the heat from the air that's leaving the building and uses it to warm up the fresh air that's coming in. It's basically recycling energy that would otherwise just be thrown away. But beyond all the energy savings, think about what it feels like for the people actually in the building. It's a huge upgrade. Since only water is flowing through the pipes indoors, there's no refrigerant in the rooms with you. And those in-room units, no fans. So it's totally silent. You just get this gentle, consistent temperature without any of those annoying drafts. And it even controls the humidity. It just feels better. Okay, so let's zoom out for a minute. This kind of technology doesn't just exist in a bubble. It plugs directly into a much bigger conversation we're all having about sustainability and what the future of our buildings should look like. And this quote just nails it. Right now, being able to prove that a building is green is more critical than ever. Everybody, from investors to tenants to city regulators, is demanding higher and higher standards for efficiency and sustainability. And that is where a system like VMF becomes a developer's best friend. It's specifically designed to crush it on those tough green building standards like LEED, BREEAM, and EDGE. I mean, a single VMF unit can help you check off a whole list of requirements all at once, which makes getting those really valuable certifications a whole lot easier and cheaper. So what it all comes down to is this. The tech we use to build our world has to evolve. Systems like VMF are showing us a path to buildings that are not only lighter on the planet, but are also just plain healthier and more comfortable to live and work in. Which really just leaves us with one big question to think about. As our world keeps changing, how are our buildings going to change with it?
So from the video, like already mentioned from the beginning, that the one unit replacing three system. So and then the benefit is is directly there. You can see that you are kind of reducing installation footprint up to 100% because our system is a kind of monoblock system. It's a very compact and monoblock system, plug and play. So it reduces also all the pipe you can see around. Try to connect the traditional system together, like maybe the air and the VRF system, everything, or the dehumidifier alone, that reduce 100%, and also the power consumption also reduce, because imagine all these individual system have compressor, and most of them also have pump around to consume a lot of energy. All that have been taken away, and the fan also taken away. Most of the fan have been taken away. So the footprint, you got really away a lot of labor, because a lot of headache from different manufacturer that also have been taken away. You have a clean roof with only simple pipe passing around. That also reduce the load on the building in terms of maybe mechanical security, or maybe a kind of maintenance, because it also reduce the maintenance, drastically reduce the cost of the maintenance. Now, because down there on everything, on the software, also on the hardware, and all the performance that you have been claiming for is 100% our responsibility. That's another big advantage. So because we don't have a separate unit again, you don't have a different manufacturer coming, or different supplier or installation company coming in. We have VMF is all full our responsibility. We cannot provide a turnkey solution with a single unit with only one company. So we eliminate all the blame, no conflict between equipment now, because we have also our software, BMS integrated VMS. We can say we control integrated system. The full system be controlled by us. Now, application, we can apply to any type of building, to be honest, from innovation to new building to complex, even so complex retrofit VME can be applied in all sectors, requiring high performance in or maybe climate control. So we can say that it's perfect for any commercial building, including hotel, hospitality, indoor pool, retail, supermarket, retrofit, or school or university. So all those can be applied, whether it's a new or retrofit. VMS can be adapt easily. So you have any project in all these fields, just contact us. We can freeze VMF working for your project. VMS also accelerate the S certification that I mentioned. That's even one of the key advantage, because with the VMF you can make at least let's say 7, because actually with the version 3 they take away the low refrigerant impact. We used to have in the version 2 Edge used to have a low refrigerant impact, but if you are going for all the certification, there's a 8 measure you can make, because they also low refrigerant impact. Like I mentioned before, VRF have the refrigerant everywhere. Or this one reduce completely that refrigerant, take away that refrigerant. So all the measure you can also help to make is the variable speed, and maybe let's say smart control also. And in Edge you can select yes for fan, because you can vary the fan. We can also variable speed for compressor, and also for any pump around the building. So all those are all variable. The fan inside also, the fan in the extractor on the unit, we can set that way. So we also have a method to put across. We can do the smart control for you. So that also can be another measure you can easily achieve through Edge. And another another measure that you can achieve through edge is that the economize the kind of free cooling, most of free heating, most time free cooling. When the outside temperature is right, we can bypass the compressor, and you can easily get a good just the fresh air in, and also the dew point control in the cooling mode. We can control the BGT also in cooling mode, and country design like the also plate heat exchanger. As you know, if there's heat in the building, they can recoup that heat to preheat the fresh air coming in before supplying your building. That's another big advantage, and the efficiency is very high also. And since we can also explore the heat from the condenser to provide the domestic hot water, that's another advantage also. Well, we know the great advantage. So we replace the fossil fuel boiler. We can also optimize on. We can also use on the floor heating and integrated heat pump for hot water, 100% heat pump. And the good news that you can also integrate with the solar. We can be integrated solar thermal. Since you integrate solar thermal, you integrate additional ventilation, the VMF behave like a brain of the building. So because there's a BMS integrated, it can work, it can calculate it for you, can analyze it for you. And if the solar is appropriate, the solar temperature is appropriate, they use the solar. When it's not, the additional heat from the compressor or maybe from the heat pump can only come in when there is enough heat. So if the outside temperature is okay, the VMF will only use the energy from the thermal energy from the solar. Now regarding additional heating, okay, we can just go to the case study. Yeah, the case study I'm going to discuss here is an office building that we're trying to compare. We're trying to put three systems together, because in order for us to convince the customer, it's a kind of one of the first building we used our VMF technology. That was 7 years ago. That's many years ago now. So we have to compare three systems together. We brought three systems together. We kind of compare them. What do we compare here? We do the case study with the VMF. We normally have hybrid hair and not the conventional hair and because we are in Denver, we use a hybrid. We are even the world leader in hybrid ventilation. So we don't use the conventional air. It should be a hybrid air and unit here. And then the VMF, the VRF with air and the unit, and also water cooled through chiller. That's the three system we try to compare together. So I prepared it. Just to summarize it quickly. I had to make the short video to make it easy. Otherwise, it will take longer to explain. See, that only 1 hour.
All right, let's get right into it. Today, we're staging a heavyweight bout in the world of large-scale climate control. This is the HVAC showdown, and we're putting three absolute titans of cooling to the test. You know, if you're responsible for a huge commercial or industrial building, this is a question that keeps you up at night. Get it right, and you've got efficiency and savings. But get it wrong, you could be looking at crippling energy bills for years. So let's meet our contenders. In the first corner, we've got the VMF, which stands for Variable Multi-Flow. This system is kind of known for being the lean, mean, efficient fighter in the HVAC world. It uses this clever hybrid of water and refrigerant to keep that energy use way, way down. And in the second corner, it's the very popular, very powerful VRF, or Variable Refrigerant Flow System. You've probably seen this one around. It's a super common choice for modern buildings. It's a real heavyweight, known for pumping refrigerant directly to different zones all over a building. And in the third corner, the old school champ, the water-cooled screw chiller. This is your tried and true super robust solution. I mean, these things have been cooling down massive spaces for decades, mainly using chilled water to do the heavy lifting. So, three different systems, but they all have the same goal: keep things cool and do it well.
Ding, ding. First up, it's round one, the power draw. We're looking at the total installed power. Which one of these systems is going to land the heaviest punch on your electricity meter? Let's find out. So where are we getting all our numbers today? Well, they come directly from this technical comparison sheet. We're looking at a true side-by-side analysis, pitting these systems against each other under the exact same conditions. We're not dealing with hypotheticals here. This is just hard, straight-up data.
And wow, right out of the gate, the data shows a massive difference. I mean, just look at these numbers. The gap between them is absolutely staggering. You can see right away that one of these systems is in a completely different weight class when it comes to chugging power. Okay, let's break this down. Coming in as our lightweight champion is the VMF system. It's got a total installed power of just over 91 kilowatts. Now keep that number in your head because that's our baseline. And now for the super heavyweight in the room, the VRF system. Get this, it clocks in at a whopping 426.6 kilowatts. That is a jaw-dropping figure when you put it next to our first contender. It is a true powerhouse. And landing squarely in the middle, we have the water chiller with a respectable 202.6 kilowatts. So yeah, it's using more than double the power of the VMF, but still less than half of what the VRF is demanding. So here's the bottom line. The VRF system demands over 4 times the electrical power of the VMF system to get the same job done. In terms of just pure energy consumption, this wasn't even a close fight. VMF wins this round by a total landslide. But hey, raw power isn't everything, right? A true champion has to be well-rounded. So let's see how they stack up when we look at something else. Okay, on to round 2, the refrigerant question. Now this is a huge deal. We're talking environmental regulations, safety, and your long-term maintenance costs. So just how much of this stuff does each system need to operate? And you know what? The results here almost perfectly mirror what we saw with power consumption. The VMF system is incredibly lean, needing only 40 kilograms of refrigerant. The water chiller doubles that to 82. And the VRF system, it needs a staggering 246 kilograms. That's over 6 times the amount of the VMF. A big reason for that is that VRF systems have all this copper piping full of refrigerant running throughout the entire building, which can have some pretty big implications if there's a leak or when you're dealing with environmental laws. All right, let's move on to our final round, the backup plan. What happens when things go sideways? We need to look at the emergency power needed to keep the essential functions running. Okay, so after seeing such crazy differences in every other category, you are not going to believe this result. It's a perfect tie. All 3 systems, the VMF, the VRF, and the water chiller, require exactly 7.5 kilowatts of additional power for their emergency heaters. It's this fascinating moment of total equality in what's been a battle of extremes. It just goes to show that some operational needs are universal, no matter how the system is designed. So, the rounds are over and all the data is in. It is time to go to the judges' scorecards and deliver the final decision. Who is the champion of this HVAC showdown? So here it is, the tale of the tape. When you put it all side by side, the story becomes crystal clear. On the 2 key metrics we looked at, power draw and refrigerant load, the VMF system is dramatically more efficient. Meanwhile, the VRF is the most resource intensive by a huge margin, and the water chiller just consistently holds that middle ground. So, what's our final verdict? Well, the VMF system is, without a doubt, the undisputed champion of efficiency. Hands down. The VRF is the absolute powerhouse. It's designed for maximum capacity, but it comes at a very high energy and refrigerant cost. And that leaves the water chiller as the balanced, reliable contender, a really solid middle-of-the-road option. And that, of course, leaves us with the final question, which is really a question for you. The data tells a very clear story, but the best system? That all depends on your project's priorities. Are you trying to optimize for the lowest possible operating cost? Or do you need the absolute highest capacity no matter the energy draw? That's the trade-off you're going to need to weigh for your specific needs. Thanks for joining us. All right.
So at the end, like I said, that comparison, we do that for all projects that where we step in. We try to do that comparison clearly we put the capacity together and make them we can compare with the customer or maybe the HVAC engineer. We look at it together. So those data are real data for this project. At the end, this is the system we install on that building. This is the VMF we install in that building. It's only one unit for kind of 1,000 square meter retail center with a 10 meter square, 20 square meter technical room or plant room with the buffer tank and a water storage tank also, small one. That's because of office we need only a small tank. We don't need a lot of water. There is only few people we need It's true there's also some shower room there, but they need a very little water storage. The buffer tank we need a bigger buffer tank for the all system just in case. The internal we need was the chill beam. Like I said before, the chill beam will work purely on fresh water. The extractor, two extractor, those are the one on the right on the right there. Those are extractor and extractor. Then the terminal was mostly used. It was a fan coil. Like you can see, it's a bit thin. It's a really thinner than the normal cassette. It also integrates very well. Like you can see on this picture here, integrate very well with the we have pipe. Only two pipe you can see. That's water and hot water and cold water going around, and the pipe are very thin. Also, you can see the thickness here. So that also gives you a lot of space. It creates more space for building. You have more space compared to cassette, which is a bit bigger. So we have a bigger. Also have a noise. This very silent. There's no noise going around there. So you can see this a bit the final product here. This is the way we were looking when we were installing, and on the right, you see that's the final product. That's how it look like. It's look very cool and amazing. There's not a lot of electronic around the building. There's few electronic around the building because it's a BMS. We're doing most of the control, and the remote control can be done if there's any issue with the technology. While anywhere in the world we can get access, there's remote access. As long as given, we can easily access your technology and help you to reset it and maybe look at there's any issue, you can be fixed. And when we simulate the same building, I'll be simulated through Edge. You can see the result here online. You can see the result on this picture. You see the result. You look at it here. I have the first measure here is a cooling. You can the one sick in green. That's what the measure will be selected. And the project was located in Stara Zagora, that's in Bulgaria. You can see here we have and we have the solar. We have the cooling. We also have selected the variable speed drives. You can see that if you look at it, that's the base case here. And when most of the time at the base case, you can see this the cooling system. The VRF, the VMF was compared against the air, the air cool. The split system, because that's what they use in the conventional same style of building, or maybe let's say the same typology in that country. The COP was 4.1. That's so the one in we kind of under at the base case. So this one also, one of the measure was a fresh air preconditioning, like I mentioned before. There's a plate it's a changer. The air, we're gonna refresh the air was coming in, or maybe if, you can precondition the air before supplying the building. Those measure, and then the additional measure, you can see the space heating. The space heating also was selected, and the domestic hot water also selected because, like I said, here we have a solar system on this building. There was a solar integrated solar. We have 65% coming from the solar and 35% from the heat pump. So that's that was a bit the condition here. And the other one, the economizer, or air economizer, like I said, when the outside temperature is appropriate, mostly in summer or even winter, most time in summer, when the outside temperature is right, they provide you the free cooling for the building. And another measure, that time we also have low impact refrigerant, because that's another version of Edge. Version 3.1, low impact refrigerant also part of it. And the last one is a smart meter, also the smart meter. Those are all the measures who have been taken into consideration. You can see here all of them are taken into that, and that will give us a result of 67.9.6% that is saving compared to a same building in Bulgaria, or maybe the same typology in Bulgaria. This only VMF measure. I didn't take account any other measure, only the VMF, only all the measure, all the functionality that a VMF can provide to you. We can save this amount of energy. See, this is the final result compared to a base case. That's the base case here. You can see the base case against the improved case with using the VMF. So you can clearly see that VMF can help us to achieve at least 67.96% in terms of savings. So, and one of the buildings have been certified already. We have a certification from Edge, so mean we have auditor who really check the building, check everything we're claiming that the VMF can save. So here I can guarantee you that that's a bit the simulation that we did with this building, and you'll be under certification soon also, because it's going through certification soon. So just if you want to start the VMF for your project or for your next project, any project you have, if you are bridging owner, architect, and so on, or you want to contact us to just for a demo, or maybe you want to visit the factory in Bulgaria, we are more than welcome. We're more than welcome to visit. So you can just contact us. So by sending your project in, so you can submit your project today. So what type of support are you going to get? You are from the EU, or you are based in the UK or anywhere in the world, because those are because UK where I'm based, and also I work a lot in Africa, but we are open to any project around the world, around the globe. Anywhere we think that the VMF is suitable for your project, you are more than welcome to submit your project. Then we'll see how we can work with you. You are going to, if your project has been selected, is suitable for, because we're open to advise. The only thing we mainly advise that if your technology, if your building are using at least minimum full functionality from Edge, from VMF, you are using full functionality from the VMF, you are more than welcome. We think that our system will be much more cheaper for you compared to any other system. If the building, that project is looking for something like cooling, heating, or maybe domestic hot water, humidity control, preheating, like I say, minimum full functionality, the technology will be very feasible for your project. So we can also help you with this with Edge certification, going through the process. If there's anything we can sometime, if the project is good, we can see how we can support to certify and prove to you that the really saving that we are planning for. And another support we are providing is a turnkey proposal we are giving you. So we help you to integrate VMF from beginning to the end. So we try to go through. So don't let this opportunity pass. Prepare your submission now. If you have any project, you can scan anytime. You can scan the QR code, somewhere around the screen, and submit your project. We can go through together and look if your project is suitable for this type of technology. So, like I said, here is for architect, engineer, developer, expert, project owner, who are looking for something different, who are really open-minded, want to go for something new, something innovative for the market, because actually, like I said, it's not a prototype. It's already real life technology. I've been implementing a lot of projects we are having now on the pipeline. We have several projects already going on. So soon, maybe in the future, I'm going to start sharing project picture of different projects we have been implementing. The complete project will be shared with you soon. So the next step for those who are maybe Edge expert, or maybe the sustainability consultant, facility engineer, if you want to become a VMF also accredited professional, or maybe an engineer who are looking for new opportunity your HVAC engineer, you want to move a bit into a new opportunity, you want to add this as part of your portfolio, feel free. We here at Danvers, we are building the future of green buildings. As at Danvers, we don't follow the trend, like we say, we develop solution and concepts. So we want to work together. So you can become a VMF, what we call accredited professional. What that is for. So your journey can start here now. So I will play with the video, and then you can understand what I mean by VMF AP, and then I will.
Welcome to Danvers Accredited Professional Program, where we aim to lead the green building industry through innovative HVAC solutions. This program is designed for sustainability professionals looking to gain a competitive edge in the field of green building certification. Our key focus is Danvers VMF technology, a complete HVAC concept integrated with building management systems. It covers heating, cooling, ventilation, domestic hot water, and humidity control in cooling mode, all while ensuring high energy efficiency. Through this program, participants will depend their expertise in using VMF concept to meet green standards like H, LEED, and more. With VMF technology, professionals learn how to optimize building performance, reduce energy consumption, and enhance indoor air quality, all crucial elements in achieving sustainability certifications. The program not only offers technical training, but also provides marketing insights to effectively communicate the benefits of our systems to clients and stakeholders. Danvers VMF concepts are versatile and designed to serve multiple sectors, including healthcare buildings like nursing homes, hospitals, and clinics. They are also ideal for retail spaces such as leisure centers, shopping malls, and supermarkets. Furthermore, our technology is a perfect fit for educational facilities, including schools, universities, and sports centers, as well as for office buildings or mixed-use developments combining office and retail spaces. After completing the structured training and certification exam, you'll receive an official accreditation, joining a network of certified professionals promoting VMF technology worldwide. This isn't just a technical journey, but a strategic one, empowering you to lead green building projects with confidence. If you're an architect, engineer, or sustainability consultant, this program offers a golden opportunity to stay ahead in the green building industry. With our global support and training resources, we are committed to making your journey towards sustainability impactful and rewarding. Ready to join? Visit our website to register your interest and get started on your path to becoming a Danvers accredited professional. Welcome.
So the first step to become a VMF accredited professional is to register your interest. You can also scan through the back, or you can contact us. You can send us the email or through the website that we just share with you, and then you complete your training. The training is only 3 days, and there's a 3 day online, and then you also you're going to travel also to Bulgaria in the manufacturer there to get your training, complete your training, because you need to touch with the hand, not only talking, and then we'll make you visit certain project site that have been completed so you can exactly understand what we're talking about. And now everything is done. You do your small exam. Everything is done now. You become an expert. We call it VMF AP, a professional. Yeah, mostly we're looking for H expert, should be consultant, like a sustainability consultant, engineer, architect, or project owner want to understand. You are more than welcome to come and visit. Yeah, it's not free, because we want to make sure that we're selecting appropriate that people really with relevant projects. If you are maybe the VMF, you are like, let's say, H expert, or maybe sustainable consultant with no HVAC at all background, you don't have anything about HVAC, and you want to understand HVAC, so we can support you. Maybe you are to become an H expert training first of all, and then also introduce you Danvers, the green building standard, marketing, sales, skills, and everything. Now, if you are maybe H expert with certification, and you already have a project HVAC, you are no HVAC, we are more than happy also to support you. That will cost you. You have no project at all, then you have to pay something. You have a project, it's okay. You don't pay anything. You are free to come. And if you have a HVAC expert certification and you already HVAC qualified, it's free. Everything's free because you already have the knowledge. The reason that it take longer to train somebody who don't have any knowledge about HVAC at all. So it become a bit difficult. We need somebody with open-minded. So the open-minded people we are looking for will be open-minded. Like I said, we already have some in Zimbabwe and Nigeria, where we even trained and visited also the headquarters of VMF, Danvers, in Bulgaria. So yeah, thank you. If you have any question, you can drop your question on the live on the chat, and then I can answer them later. Drop them so in the chat comment, like I said. So I will answer them if I manage to read some, I can answer them now. Let me check if I can see there's any question. Otherwise, like I said, I will come to you later. Yeah, I can also answer them. I'll come to you later. In the future, we're going to make it a bit more live interactive. I mean, this only the kind of we are seeing kind of settle our understand our routine, try to make it a proper interactive class. That would be the mostly interactive. It's only about, even like I said, it's not the webinar, it's not conventional webinar. It's only about may you understand, be aware about this paradigm shift was happening, that we're bringing in. Not only that, we're not improving only, we're not just improving our aim is only, it's not only about it's not about what I say, it's not about just kind of improve the HVAC system. What we're trying to do here, we're trying to create a new way. So bringing in go away from the heavy refrigerant based HVAC system to also go away from the recirculating. You see, the recirculating based HVAC system and different components. So we want to put that in one compact and monoblock system with one responsibility, not a lot of responsibility, not a lot of supply, we know that maybe it might not look good for certain HVAC engineer because they think that we are bringing in we're taking away a lot of labor, we're taking away but our idea was built to, we were talking about sustainability. We need to reduce the amount of traveling around the site. We want people to operate because energy. We want people to operate low. OPEX, reduce the OPEX also. That's good because low maintenance. And another thing also, we want to reduce the amount of labor around the beach. I already mentioned that. So that's a bit the idea, and we also give a chance to a small company, to small HVAC company based or anywhere in the world to compete for big projects, because most of the time there's a big challenge there. The small HVAC company cannot compete for big projects because they cannot handle we need handle a lot of HVAC around the project, a lot of different components of the HVAC system. Sometimes they only focus on small project. So we're giving a chance also small company anywhere in the world to go for massive and look a bigger opportunity around the globe. That's a bit the advantage here. Okay. Thank you for listening. Thank you for your time again. Okay.